everyone. All right. So in 1950, when Alan Turing first introduced the concept of the Turing test, the first test of comparing human and machine intelligence to each other, I wonder if he thought that we would be where we are today, 70 odd years later. Perhaps he was one of the few who actually thought that we would have reached machine learning or human intelligence in machines by now. Maybe even thought it would have gone a bit quicker. I think that when we think back on the last couple of years, absurd speed in development, we forget that AI has been a struggling research field for about 70 years. Started out in '56, then went down 2 downturns in investment over that course of time, only to finally land on a working transformer architecture in 2017, when a then little-known company called OpenAI put a big bet on scaling that transformer architecture. That then turned into an entirely new market that is now disrupting industries all over the world. And that's what I'm here to talk about today, how that market is transforming and what that means for all companies, more or less. My name is Jesper Hagberg. I work for a company called Generate, a newly started AI agency, aiming to be Sweden's leading AI agency over time. Prior to that, I co-led and created the Global AI Initiative at ASSA ABLOY here in Stockholm. We went from me as the sole employee there up to 10 employees by a few months ago. We created a technical team for development of AI, went through a lot of ups and downs, made a lot of mistakes. And we created a more business-oriented team to find and identify business opportunities throughout the organization, did a lot of networking, set up an ambassador network, a champions network, in order to start funneling ideas to see what we could do with generative AI. We also dealt with the question of responsible AI, dealing with AI policies, AI guidelines, AI directives, and so on. Very much focused on, of course, the AI Act, which I imagine a lot of you will have had conversation internally at your companies about as well. Finally, we worked with what I think a lot of people think about with AI adoption, and actually getting people to use the things that we're proposing that they use in many times, whether that be something that we source externally or something that we develop within our own companies. We have to get people to actually use them, which means a lot of engagement. And there is a lot of old legacy systems, such as intranets and so on, which makes it hard to reach people if the companies are that large. And ASSA ABLOY at the time had 61,000 employees. I think they're now up to 67,000. So I will start today by giving a bit of a background as to why this is a thing and what's happening with the AI market at the moment. And the reason for that is I think that it's important that we go back to sort of the why of what's happening and how that is impacting us. I will then attempt to, at least on a conceptual level, talk about how to identify new business opportunities. And finally, I will talk briefly on how that impacts sort of the question of data, which has been on everyone's mind for the past 20 years. So for the market, I have done a classic generative AI value chain. And as with all models, they are wrong, but some are useful. So hopefully this creates some sort of structured view if you haven't heard it before. If you already have heard it, then you will get sort of a catch-up on or a reminder on how it looks at the moment. But typically when we look at generative AI, at the top, we talk of an infrastructure layer where sort of the railroad tracks of this technology is laid. We've got the chip manufacturers, NVIDIA, AMD, and Intel. We've got the large cloud providers, whenever we need access to compute that way. And then we have compute services for more personalized compute, where if we want to run something on-prem, but we don't have access to the underlying GPUs ourselves. They, of course, provide technology down to the technology which made this area explode, which is LLMs, or it's also known the foundation model layer. And here we talk about 2 different kinds of business models in this field. It's closed versus open. And this is nothing new. This has been around ever since Bill Gates and Steve Jobs fought about it in the 70s and 80s. And it's now the same within AI. But typically, the closed source model providers are the first one that were out the gate. OpenAI, Anthropic, Google. I'd put Amazon here as well. And then, of course, the open source, where the underlying weights of the models are made available so we can run them on our own GPUs, was primarily done, or most famously done, by Meta, and later by DeepSeek in February this year, which sort of sent a shockwave through the entire AI world. There's also Mistral AI, and then I included Google DeepMind to essentially point out that Google are in a lot of different places in this. The same is true for Microsoft, and the same is true for Amazon. Then we have the area where most things are happening, so the application layer. And here there are a number of things happening. So number one, we have the enterprise apps, SAP, ServiceNow, Salesforce, and so on. I'm sure you're familiar with all of them. They are making a lot of features with AI at the moment, because of course they're scared of all the startups coming as well. And they will of course charge you and other companies for this sort of added features. Then we have the vertical specific apps. So when we look at very specific areas where there aren't large enterprise apps at the moment, a good example I think is legal, where Harvey, which is an example here, has sort of exploded across the world over this year, one of the big winners in the application later this year. Or Jesper for marketing, or Runway for video editing, or the final one, the box is Cursor. And then we have the consumer apps that go broadly, that everyone will want to have access to. And here we all as companies have to think about sort of what features do we want and what do we need. When do we need the enterprise features? When do we need the vertical specific? Because the type of work we're doing is so specific that we need maybe a smaller provider that is a bit more specialized. And on the consumer side, maybe everyone will want that, because it will be so standardized in a few years that we simply will take it as much as granted as we have with Google over the past 15 years. Finally, we have the end users. And this is where we find most companies at the moment. We're recipients of this technology for the most part, right? So you'll have businesses that bring in order because they're afraid of data protection, and rightfully so, I think. And then you have the consumer side. And I will blow this up later on, so you'll see it a bit better. But typically, it will follow the same trend as all technologies have before, with early adopters, late adopters, and so on. So that's the whole of it. So now we have to sort of start thinking about what happens in each of these areas in order to actually figure out what do we want to do as companies in it, and what position do we want to take in this market. So in the infrastructure layer, this is an extremely resource-intensive place because making chips takes a long time. They have R&D cycles of up to 15 years. It's also a market greatly impacted by geopolitics, primarily US-China relations. And as a result of all of that, there are very few new entrants. I think OpenAI is the only example that I'm aware of who has actually entered this space in the last couple of years. The same can be said for the foundation model layer. Although there is a lot more competition here, there are very few companies actually making large language models, and as I think most people know, the reason for that is that it's extremely expensive. GPT-4, for instance, was estimated to have cost $41 million USD in computing costs alone. That does not take into account the R&D time spent or anything like that, only the running of GPUs. And the result of that is that competition is higher than in the layer above, but still very limited, and very few companies will be able to play here, also because of the AI talent being extremely scarce. Finally, we have the application layer. And here, all of the competition is happening, more or less. This is the, by far, most rapidly moving layer in the world. And it's because it's quite easy, or easy quote unquote, to develop AI solutions because the LLMs are readily available to us. Of course, we still have to find good applications for them, but technology-wise, it works. So new entrants are coming all the time. There are thousands of startups. There are a lot of features, as we said, in the enterprise apps. There are new consumer apps coming. And it's generally considered to be the competitive battleground of AI. And over time, it is also believed, although this is a bit speculative on my part, I apologize for that, but that this is where the value will be had at the end of the day. And this comes down to sort of comparison to prior technology paradigms. If you look at when social media came on the scene, for instance, those apps are completely reliant on underlying technologies such as 5G and Wi-Fi. 5G and Wi-Fi is primarily dominated by companies such as Ericsson, Qualcomm, Nokia, and so on. That's a billion-dollar industry. The industry that it enables, social media, is a trillion-dollar industry. So it's believed that it's supposed to go in the same direction here, where the foundation model layer will supply the infrastructure or the sort of railroad tracks, as I said before, and the application is where the value will be had closer to the actual customers. And finally, end users. Here there is currently a race for adoption. All companies are talking about AI adoption. And it's about being as fast as possible because we're afraid of losing competitive edge. It's probably not about being competitive. It's more about staying competitive. And in order to make this work, we need to adapt to the application layer, as I mentioned before. We need to bring in the solutions that the employees and people that work in our organizations want. And it's not just one solution that does that. I've seen plenty of examples of companies simply bringing in ChatGPT or Copilot or Claude in some rare instances and thinking we're done. Probably not. A lot of different areas and verticals will need their own applications and so on, which creates a bit of a tricky position for slow sourcing processes and so on. And finally, consumers will adopt in the same rate or in the same way they always have as a normal distribution. And here the trick, of course, is squeezing it as much as we possibly can. So finally, what does all this mean? Well, it means for most companies, we're looking at the two bottom layers. As I said before, we're not going to be creating large language models. Most companies won't be creating chips. But all companies will need to adapt. And a lot of companies has their own sort of expertise and a lot of specialized knowledge that can be used here. So you have to think quite hard on whether or not we want to bring applications to the market ourselves by using this technology. So that's number one. And number two, we need to empower employees to use generative AI applications to boost AI adoption. Now, in the interest of time today, I won't speak too much on the second one here, but I'll mention it briefly now. And this is about change management at the end of the day, getting people to work in different ways. And it's a lot about engagement. It's a ton about working hard to get people to actually understand the value of how this can be worked in their own working processes, whether that's ChatGPT or if it's Jesper or any of the other ones we bring in, or if it's something that we develop ourselves. But as I said, I won't be focusing too much on that now. I will instead talk about what does it look like when we look at new business opportunities. And this has much more to do with the application layer than anything else. And this is tricky. The companies today have a very, very complicated situation. We have a market where there are thousands and thousands of new features and applications coming all the time. And we have an internal sort of logic at our companies where people have thousands and thousands of ideas. And so you need to keep track of this extremely complicated market, and you need to keep track of a very complicated internal landscape. And I think the primary focus that we should be focusing on is the internal world, to see what are people saying. People that actually work out in the organization, what do they think that we can use this technology for? And that requires us to have a pretty good structure in how we collect and assess ideas at companies. And I know that I've had a bit complicated slides up until now, but I like to use simple ones as well sometimes. Typically, this isn't rocket science on a conceptual level, right? We want a broad idea identification first. Now, this is easy to say, very hard to do. We need to talk to a lot of people out in the organization. We need to give them ways of reporting the ideas they have or how to use this technology. We then need to have ways of refining that ideas that are standardized so we can actually compare the ideas to each other. So how are we actually creating business cases? How are we assessing the technical feasibility? And finally, we need to get very good at decision making, and we're going to need to speed this cycle up a lot. Because the thing that generative AI does, it embeds itself into this. So everyone is getting quicker at this now. Making a business case today takes a lot less time than it did yesterday, for instance. So I go into each one of these in a bit more detail here. Typically on a broad idea identification, we're looking at opportunity identification first. This hasn't changed too much, to be honest. This is a lot of networking. This is providing one good place to send in your ideas and so on. But then in the other steps, things have started to go a lot quicker. So you still need to do ROI and risk analyses for all the ideas coming in, but we can use AI to do so. So we can do it very, very, very much faster than we could before. It also requires a bit more specialized knowledge. ROI in AI, you need to understand how the cost structure works, how the inference cost works. If we're doing it on-prem, what is the cost of actually getting access to the GPUs we're running it on, and so on. On the terms of ROI, there is an emerging legal landscape where we have the AI Act connected to the GDPR, the Data Act, and then industry-specific legislations. These don't really talk well to each other, so lawyers are debating what you can do and what you can't do, meaning that lawyers need to be a part of this as well. Finally, we have technical feasibility, where we need to understand what is the technology we actually need to do this. We also need to understand the data landscape within our internal organizations. This is competence that is not held by business or by risk, typically. This is sooner held by IT departments. And they understand how the data looks today, what is required to collect it, what is required to actually process it. And then, of course, we need to understand how many APIs do we need to integrate towards, because that's usually a huge bottleneck when we're doing AI use cases. And we need to figure out the data orchestration, which means we need another competence here as well in order to even be able to do this. So this has to be an interdisciplinary approach. We need people who knows the law, we need people who knows the business, and we need people who knows the technology. Only then can we actually make this broad assessment of what is actually doable and not. And that will end up in an opportunity prioritization. Then we need to keep working with these. And this, once again, is not rocket science on a conceptual level. We're talking about, we've always done workshops and interviews and requirement workshops and whatever we want to call them to understand what it is we need to, what the needs of the users are. What has changed a lot is, of course, that we now can we can transcribe the calls to get all the data. We don't need to take the physical notes. Hopefully we can bring down the number of meetings a lot by designing them in a good way. We can also make rapid business cases because we can generate them using generative AI. If we're good at writing prompts so that it's standardized, so it standardizes the output, we can actually get business cases extremely quickly with at least 80% good enough level. And then, of course, the big thing that I think has happened with generative AI is that we can do rapid prototyping in a stage before we actually make decisions. We can get something in our hands that we can actually test out and we can give to users, because the cost of doing so has been brought down so much by tools like Cursor, like Lovable, for those of you who've tried that. So you can actually just start trying these things out. And it's a rather low-code approach. You don't really need that much technical expertise to do so. And finally, we need to figure out what decisions can we make on these. So we've brought this down. I think this takes us roughly now a week to go through one of these. And then, of course, is the decision-making times. We're huge fans, typically, of doing alignment meetings on alignment meetings on alignment meetings before we actually get to a point where we do the investment and we start the work of actually putting things into production. Well, in the world of generative AI, and I think in a lot of other cases, there is more or less only 4 decisions that we need to take into account. Number 1, we can buy features from a current supplier. This means that there is always already an agreement in place, which makes things a lot easier. It's usually a bit quicker. Also, because of the high competitive, how competitive market they're operating is in, they're usually very willing to do this at quite a low fee. The second is, well, we can't really reach the level of functionality that we want with an existing supplier, so we need to bring in some new, maybe smaller actor, maybe vertical specific, as I mentioned before, or we simply want to reduce our dependency on large suppliers, for instance. In that case, we'll buy from a new provider, but that means we need to set up a new agreement, we need to source it, so we need to now understand what are the questions we need to ask the suppliers in order to make sure that our data is safe, for instance. So once again, we need to bring in more competence in order to do so. Finally, it's build. Now, what I mean by build here is essentially however you do it, we own the underlying IP. So you can bring in a partner to do it, you can hire people to do it, you can use consultants to do it, but in the end of the day, it's that we own the solution. In my mind, and if you disagree, I'm happy to talk about this after, but the only reason we would do this is if we want to do something with the IP, i.e. bring it to market, because this means that we need to deal with the hosting, the support, the development, and so on. So we need to justify that cost somehow. Essentially, we want to build something that we then put to market in the application layer that I mentioned before. And that we need to think pretty hard about, because usually I don't know exactly what the companies that you come from, of course, but if you're manufacturing physical products, it might be a bit strange to go with software solutions to the market and so on, but that's sort of the true disruptive nature of this technology in my mind. And finally, and quite importantly, we can choose to ignore. If we do this cycle fast enough, then we can avoid having a sunk cost fallacy, where we sort of fall in love with our ideas and we have a very hard time saying no. We should track ourselves on how good we're saying no, because there's so many ideas out there. So a no is still a good decision, as long as it's made. The point is that we have actually, okay, let's move on to the next idea and let's get going again. Finally, to summarize this a little bit, successful innovation in this field is about processing a lot of ideas. It's different for each industry, of course. So the 20% over here is completely arbitrary. If you're in pharma, you'll need to go through thousands of ideas. If you're in manufacturing, it's typically assessed to be hundreds of ideas. But it's usually at least in the magnitude of hundreds that we need to be able to process to find a few good ones. And the consequence is that if we don't have a structure that actually facilitates this innovation, we get undefined and unclear business value. We get sunk cost fallacy issues that I mentioned before. And we get suboptimal prioritization of our AA initiatives. Finally, where we want to be is, of course, a classic funnel. It doesn't look different today than it did yesterday. It goes a bit quicker, but it's not magic. There is a percentage that we want to put through this funnel, and we want to do it as quickly as we possibly can. And we can now do it quicker than we ever have before. Although internal politics and internal corporate structures and so on sometimes makes it quite difficult. Finally, what does this mean for managing the data? Because you can't really talk about AI without at least addressing data. They are sort of interconnected to a degree that is, well, you don't speak about one without the other in my mind. I'm going to do this with one slide, I hope. Typically, if we take one AI use case, this is typically what you'll see. We'll have a few documents in the beginning. We'll send those over. Some developer will sit, figure something useful out to do with that with generative AI. And you'll have a very quick initial development phase. And then you say, yes, we want to go into production, and now we need to figure out where all the data is, and everything stops until we figure that out. This is true for every single Gen AI use case I've seen. And it doesn't matter if we build something or if we bring in an external tool, because we want it to run on our data. So this will always happen. And as this cycle of innovation speeds up, you'll have this in every single case. And it then becomes very enticing to start to sort of address the root cause. So we want to create a data lake, a data mesh, a data fabric, in order to solve that for all our use cases. The issue with that is we're turning our attention away from the value and addressing data instead. So if you do that, you're going to address a lot of data that is not useful. So in my mind, I hopefully think this question is sort of dealt with, because I think this should be done on a use case by use case basis. You should get better and better at data mapping. You should get better at API integration and data orchestration over time. And for each use case, that's going to go quicker. And then the underlying data will slowly increase in its quality, rather than trying to do the monolithic thing and solving it all at once. So with that, thank you for your time.